left or right, blah, blah, blah. All right, so let's kind of go back to the original question, or the first question, not the original question, but the first question I talked about in this live stream, which was completing the square. And the way I talked about completing the square was going from vertex form to, standard form to vertex form. And we did that by creating a perfect square trinomial. Now, a perfect square trinomial, again, is a trinomial that can be squared into a binomial squared. And so therefore, obviously, if we have one, then we can just go ahead and factor it. If we don't have one, then we have to create a perfect square trinomial. So in this case, since we knew x squared plus 5x plus 9 was a perfect square trinomial, I just added a 9. But we recalled you just can't randomly add a 9. If you're going to add a 9, you're going to have to subtract a 9. But then you can go ahead and go about your business. Now, typically, if I had to graph something in standard form, I would look into, if I just needed to like sketch a graph, I typically would look to see if I could find the zeros, the x-intercepts, and then I'd just kind of look at the behavior of the graph. Is it opening up or opening down? So if you knew the graph was, for instance, if I had y equals x squared minus 5x, let's just say, minus 6. So if I had to graph this equation, I would just factor it. And I'd say x minus 6 times x plus 1. The graph is going to open up because the x squared is positive. So I'd say like here's 6, negative 1. So the graph's going to look something like that. And typically for most applications, that's really what we need. Sometimes it's going to be helpful though to find the vertex, right? Or like the minimum value. So that's where we kind of come into a problem with this function or this equation, is because we can't really complete the square. This does not produce even or nicely produce a perfect square trinomial. So if you look at all the perfect square trinomials, we're not going to have 5. So therefore, in this case, what we're going to want to do is follow the algorithm to be able to create a perfect square trinomial. And to do that, all you need to do is take your middle term, divide it by 2, and square it. So in this case, we're going to take a negative 5 divided by 2 squared, which is equal 25 fourths. So that is the number that completes the square. It's just like the number 9 that completed our square in our first example. So what I'm going to do is I'm going to take y equals x squared minus 5x plus 25 fourths. But again, you just can't randomly add a number to an equation. You're going to have to subtract 25 fourths, and then you're going to have to add 3, right? Because the 3 is still there. Now, remember, you've now created a perfect square trinomial, which can now be factored into a binomial squared. The factored form of this is where students usually have trouble though, is just going to be this b divided by 2. So all you're going to do is do x minus 5 halves quantity squared. And then this one, let's go ahead and let's do this work here on the side, because a lot of students do not like fractions. So we want to make sure we understand that. So let's multiply by 4 over 4. That's going to be 12. So this will be a negative 13 over 4. All right, so negative 13 over 4. So again, we still need to graph this, right? Now, the nice thing about this, having in vertex form, is we know our vertex here is 5 halves, and our y-coordinate is going to be 13 fourths. So you can see why when I originally looked at this problem, like, why would you want to graph this? Because this isn't going to be anything nice. Like, I'm not going to give you a nice sketch of the graph of what this graph would look like. The important thing is understanding maybe the vertex, the shape of the graph. It's not like a nice it doesn't have nice intercepts. But we can estimate here. So if I was going to estimate, that's going to be what? That's going to be like 2.5. And this one, 4 goes into there. So that's going to be 3 times, so 3.25. So I'll just go ahead and sketch that. So x coordinate is 1, 2. So 2.5, and then up 1, 2, 3. So something like this. And then again, the graph is going to open up. So there you go. You can see that it doesn't have any x-intercepts. So that's why this method wouldn't have helped us out. You could also create a table and just plug in numbers. Typically when doing that, though, you want to find the axis of symmetry